Alright, let's start by reading the problem description. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Example 1, we have an array of numbers and a target of 9. We can see that 2 plus 7 gives us 9, so our output should be the 0 and first indices. Example 2, we can see that 2 plus 4 gives us our target of 6, so our output should be the first and second indices. Example 3, we can see that 3 plus 3 gives us our target of 6, so our output should be the 0 and first indices. For our constraints, the length of the array will be greater than or equal to 2 and less than or equal to 10 to the fourth. The values in the array and the target will be greater than or equal to negative 10 to the ninth and less than or equal to 10 to the ninth. And only one valid answer exists. For our follow-up question, can you come up with an algorithm that is less than big O n squared time complexity? Which we can and we will in our optimized solution, but first we're going to go over a naive approach with quadratic time complexity.
For our naive approach, we're going to utilize a brute force solution. This solution has a big O of n squared time complexity and constant space complexity, because although we're going to store some values, those values do not grow relative to the size of the input. The general approach is we'll use two for loops, an outer and inner loop, to sum up the values in the array and then compare that sum to our target until we find our target sum. So we'll diagram example 1. The outer index will start at the 0 index, which is 2, and the inner index will start one index ahead of the outer index because we're not allowed to add the same number by itself. So that gives us an inner index of 1 and an inner num of 7. 2 plus 7 gives us a sum of 9. Finally, we check if sum equals target. If it does, we return the outer and inner indices, which in this case, this evaluates to true and we return the 0 and first indices. Let's try a target of 26 to help further illustrate this approach. Since neither loop iterated on our previous example, we can leave the current values. So our sum of 9 does not equal our target. The inner index increments by 1, giving us an inner num of 11. 2 plus 11 does not equal our target. Inner index increments. 2 plus 15 does not equal our target. Inner index increments again. This gives us an index of 4, which is out of bounds of our array, so the outer index increments, giving us an outer num of 7, and the inner index resets to the outer index plus 1, which is 2. This gives us an inner num of 11. 7 plus 11 does not equal our target. Inner index increments, giving us an inner num of 15. 7 plus 15 does not equal our target. Inner index increments, which is out of bounds, so the outer index increments, giving us an outer num of 11. The inner index starts at 3, giving us an inner num of 15. 11 plus 15 equals 26, so our sum equals our target, and we return the second and third indices. Okay, let's translate this into code. Okay, first we'll start by creating our outer for loop. We'll initialize an outer index with a value of 0. For our condition, we'll check that the outer index is less than the length of our array, and then we'll increment our outer index by 1 once the code block is finished executing. We'll store the outer number in a constant called outer num. Next, we'll set up our inner for loop. For our inner index, we'll initialize it with a value that is the outer index plus 1. For our condition, we'll check that the inner index is less than the length of our array, and then we will increment our inner index by 1. We'll store the inner number in a constant called inner num, and we'll also store the sum of the outer num plus the inner num. Finally, we'll check if our sum equals the target. And if it does, we'll return the outer index and the inner index. And that's our solution. Let's run this against our test cases. And we get the expected output. Let's copy paste this into Leetcode to check that it passes. Okay, let's paste it in here. Hit submit. And our solution was accepted. Now let's diagram the more optimal approach. For our more optimal approach, we're going to utilize a single for loop and a hash map, also known as just a plain old object. This solution has a big O of n time and space complexity. The general idea is we'll have our for loop iterate through every number in the array, and each iteration will take the current number and subtract it from the target. Then we'll check to see if the difference is in our hash map. If it is, we'll return the index of our current number and the index of the difference in our hash map. Else, if the difference is not in our hash map, we'll add the current number to the hash map and assign its index as the value. Let's diagram example 1 again, but this time we'll use a target of 18. So the for loop index will start at the 0 index, which is 2. 18 minus 2 is 16. We check if 16 is in our hash map, which it is not because we have an empty object to begin with. Then we check if our current number, 2, is not in the hash map, which it's not, so we add 2 as a key and assign its index of 0 as the value. Our for loop index increments to the next index, which has a value of 7. 18 minus 7 is 11. We check if 11 is in our hash map. It is not, so we check if 7 is in our hash map. It's not, so we add 7 as a key and assign its index of 1 as its value. The for loop index increments again and we have 11. 18 minus 11 is 7. We check if 7 is in our hash map, and it is, so we return the indices of 7 and 11, which is 1 and 2.
Okay, we'll start by initializing a constant called hash map. We'll assign it an empty object as a value. We'll set up our for loop. We'll initialize the index with a value of 0. We'll check that the index is less than the length of our array, and we'll increment the index by 1. We'll store the current number in a const called current num. We also create a constant called difference, the value of the target minus the current num. Then we'll check if the difference is in our hash map. And if it is, we're going to return the indices of the difference and our current number. Else, if the current number is not in our hash map, we'll add it to the hash map and assign its index as the value. And that's our solution. Let's run this against our test cases. And we get the expected output. Let's copy paste this into Leetcode to check that it passes. Okay, let's replace our previous solution with our new solution. Hit submit. And we get an accepted answer that has a better runtime than our previous solution and a slightly worse memory than our previous solution.